Up to now, we've only looked at cases where the interest was accumulated. Up to now, we've only considered cases where interest was accrued on an annual basis. However, it's possible most of the examples that we've done so far, the interest was accrued on an annual basis. However, when we looked at the annuity example of the house mortgage, we had to convert the annual nominal rate, the stated rate in the mortgage, to a monthly periodic rate. Implicitly, interest is being charged on a monthly instead of an annual basis in that house mortgage example. Compounding more frequently than once a year results in a higher effective interest rate because you are earning or paying interest on interest more frequently. As a result, the actual effective interest rate that is paid is greater than the nominal or stated annual interest rate. The effective rate of interest increases more frequently. Furthermore, the effective rate of interest will increase more frequently. Furthermore, the effective rate of interest will increase the more frequently interest is compounded. So for example, let's assume we want to calculate the future value that we would have obtained from investing. So let's look at the future value that we would arrive. So let's look at a future value that would occur from investing $100 at 8% interest compounded semi-annually over 24 months. So for the first 6-month period, our beginning principal amount would result in an interest rate of 4%, so 8% per year, or per 6 month, 4%, so 8 divided by 2, so 8 divided by 2 gives us 4%, so 100 times 1.04 gives us a future value at the end of that first 6 months of $104. And then for the next 6 months, our beginning principal would be $104. That was our ending amount from the end of the first 6 months. We would take that $104, multiply it by 1 plus the 6-month interest rate of 4%, and we would have $108.16. And we would continue that so that at the end of the 2 years we would have $116.99 if we had invested $100 at 8% interest compounded semi-annually over 2 years. We can see then if we would have with annual interest at the end of 2 years we would have had $116.64, and as we just saw with semi-annual interest compounding we'd have $116.99, and we could also compound quarterly or every 3 months, and if we'd have done so we would have arrived at a future value of that $100 of $117.17. So our general equation for finding a future value when we have compounding occurring more frequently than annually is the future value is equal to the present value multiplied by the nominal annual rate divided by the number of compounding periods. So this part right here, this would be the semi-annual rate, the monthly rate, the quarterly rate, so forth, raised to the number of compounding periods per year multiplied by the number of years. Alternatively, we could calculate an effective or true annual rate. We call that the effective annual rate, EAR. The nominal rate or stated rate is a contractual amount. So this is going to be the amount that's in any loan document. However, if we're having more frequent than annual payments, the actual true interest rate that we'll pay will be higher. So to calculate the effective annual rate, and the effective annual rate is greater than the nominal rate whenever the compounding occurs more than just once per year. So if compounding occurs once per year, the effective rate is the same as the nominal rate. But assuming a positive interest rates, the more frequently the compounding, the higher the effective annual rate is going to be. So the effective annual rate is equal to 1 plus the periodic rate. Again, this would be the rate per month, per quarter, per 6 months. So the annual rate divided by the number of compounding periods arrives at the So the annual rate divided by the number of compounding periods gives us the periodic rate. So 1 plus the periodic rate raised to the number of compounding periods per year, and then minus 1 gives us the effective annual rate. So if we calculate the effective annual rate associated with our 8% nominal annual rate example, when interest is compounded annually, semi-annually, and quarterly. So with annual coupon paying interest, we'd have just one compounding period per year, and the effective annual rate is the same as the nominal rate in that case. But when we have semi-annual compounding, our periodic rate is just 4%, or 0.04. The 8% divided by 2, raised to 2 compounding periods per year, gives us an effective annual rate of 8.16%. And the effective annual rate with quarterly compounding, so the annual rate divided by 4, raised to 4 compounding periods per year, gives us 824%. Now, as an exercise for you to do on your own, apply the $100 present value to 2 years at a rate of 8.16%, calculate that future value, and you will find the same $116.99 that we obtained using the other formula, obtained using this formula right here. We can also have continuous compounding. And in continuous compounding, compounding can be on a semi-annual basis, quarterly basis, monthly basis, a weekly basis, a daily basis, an hourly basis. If we wanted to continue that out, we'd have the case of continuous compounding, which involves the compounding of interest at an infinite number of times per year. So we're thinking here of intervals of just microseconds. The general equation for continuous compounding is the future value is equal to the present value multiplied by e, our natural exponent, raised to the rate times the number of periods, the number of years. Each compounding period that we add increases the effective annual rate, but it increases at a decreasing rate. So again, our principal amount of $100, a stated nominal annual rate of 8%. If we had one compounding period per year, the effective annual rate would be 8%. The future value in 1 year would be $108, and the future value after 10 years would be $215. If we had semi-annual compounding, so 2 compounding periods per year, the effective annual rate was 8.16%. The future value in 1 year is not much difference, right? It's only 16 cents more compared to compounding on an annual basis. And after 10 years, though, the difference grows to about what? Somewhere between $3 and $4, between $2.19 and $2.15. If we had monthly compounding, 12 compounding periods per year, the effective annual rate is 8.3%. And after 1 year, we would have $108.30. Not much difference than if we had annual compounding of 108. However, if we look after 10 years, the future value at 8% annual rate compounded on a monthly basis is about $222 versus about $216. So it begins to show up as we have more compounding periods and longer periods of time than it does when we just have a single period in time, so just 1 year. So the difference between compounding once per year and compounding 12 times per year is relatively small if we're only looking at 1 year, and if we look at 10 years, we begin to see more of a difference. We could also have weekly compounding, and notice going from monthly to compounding to weekly compounding, there's not much change in the effective annual rate, and there's not much change in the future value even after 10 years. If we had daily compounding, just assuming a 360-day year, the effective annual rate would only be 3.227%, and that future value after 1 year, I can't even tell the difference between daily and weekly compounding. Likewise, there's only a few cents difference going out 10 years. And if we look at continuous compounding, the effective annual rate is 8.3287%. So the effective annual rate for continuous compounding is not hardly any difference than we would have from daily or weekly compounding. And after 10 years, if we had continuous compounding, we would have $222.55, whereas with daily compounding, we'd have $222.53, and then with weekly compounding, $222.42. So the effective annual rate increases with the number of compounding periods per year, but once we have many compounding periods per year, the incremental benefit of adding an additional compounding period is pretty small. As we can see, when we go from 12 compounding periods per year to continuous compounding, there's not a whole lot of difference there. And we can see this here graphically on a chart where we have the number of compounding periods per year on the horizontal axis and the future value in 1 year on the vertical axis, and we can see that most of the benefit occurs when we have 6 compounding periods per year, and then there's very little to gain from additional compounding periods.